Alright guys, we're going to go over a few of these problems. They are not hard, same thing we've already been doing. First thing we need to do, so we know we're just doing kinetic energy problems, so this is going to be pretty straightforward piece of cake, right? So let's write the formula for our kinetic energy. Check your formula chart if you don't have it, but kinetic energy equals 1/2 mass times velocity squared. Pretty straightforward, pretty easy, right? If it's moving, it's got kinetic energy. If it's moving, it has mass. So let's look at this first one. We're going to skip around, not very hard. This is more of like a check your work kind of deal. Kinetic energy of this. So the first few, I'm going to do them kind of the longer way. Not super long, but let's write our mass off to the side. Mass equals 750. It's kilograms. Velocity equals 14. Formula, kinetic energy equals 1/2 mass times velocity squared. I know you're all in a hurry. It doesn't hurt to rewrite everything every problem. I know we just wrote it, we wrote it again. It doesn't hurt. I know you're in a hurry. Just think about like, hey, I'm willing to pay 2 extra seconds a problem to get like exponentially better at this, right? So just keep that in mind. All right, so kinetic energy equals 1/2. Mass is 750. Parentheses that. And velocity is 14. Remember, rookie mistake, they don't square it. Why did I get this? Why is my answer so small? It's because you didn't square it, my dude. You got to square it, right? So that's what the redundancy of writing it over and over again is, right? So punch that in the calculator. We know because it's energy, it's going to be in joules. So I'm going to box my answer that I'm about to get. I'm going to write joules here because I already know it's going to be in joules. And 73500. So that's my energy in joules, right? Pretty easy, pretty straightforward. Let's look at the next one. A rifle can shoot at 4.2 gram. Can shoot a 4.2 gram bullet at X speed. Okay, so let's write my stuff off to the side. I want you to. Here's another rookie mistake that makes people get things wrong. Because they get confused, right? Or they don't get confused, they just don't do. Our baseline is kilograms for mass. Notice this is in grams, which means we're going to need to change that. Meters per second, we're good there, but we're going to need to change that, or else we're going to get a whacked out answer, right? So let's do our stuff off to the side. Mass equals, so if we're going grams to kilograms, I believe that is 3 places to the left. Hopefully you guys got that down by now. If you don't, just do your formula chart. Plug it in, just check it. So our mass is actually, 1, 2, 3. 1, fill it with a 0, fill it with a 0. So 0.0042. So we got that. And our velocity is 965. We're not squaring it here because we're just writing the velocity, right? So kinetic energy equals 1/2 times 0.0042 mass times velocity 965 squared. So I'm really just speaking the formula out loud, right? I'm not going to make a noob mistake and not change that to kilograms, and I'm not going to make another noob mistake and not square that, because I write things over and over again so I don't make mistakes, right? Okay, so that being said, we know it's going to be joules, and we should punch that in the calculator. 1955.57 joules. Yo, I got 19,555. That's because you didn't change this. If you get a bigger number than this, like the decimals here, that means you didn't change this, right? So, remember, you got to convert that. That ain't no good. All right, let's do the next one. A bike rider. Are we up high enough? All right. A bike rider is equipped with a monitor measuring his energy output as he approaches a hill. Has a speed of, that's very weirdly written. Whatever. As he approaches a hill, he has a speed of 8.5 meters per second, and his energy output is 3.1 times 10 to the 3 joules. What is his mass? Okay, so now we get to do something a little bit different. That's a little refreshing. So let's write what we got. So velocity equals 8.5. Energy, we know it's kinetic energy because the whole page is called kinetic energy, but also that's velocity, so it's got to be kinetic, right? Or else we wouldn't have been able to figure it out. Equals, I'm going to convert this because I don't want to mess with scientific notation. So I'm moving this decimal 3 places to the right. So it's going to be 3, 1, 1, 2, 3, 0, 0. Right? 3,100 joules. You look at this, 1, 2, 3, fill these with zeros. Pretty easy. We don't know mass. So our kinetic energy is 3,100 equals 1/2. We don't know the mass times the velocity, which is 8.5, squared. We always follow our formula. We don't forget to square. So what do? This isn't what I'm used to. Okay, no worries. No worries, my dude. Check it out. So you're going to square this first. I don't have a calculator. I guess I should calculate this. Square this and then times it by 1/2. See, 8.5 squared is 64. Okay, I'm going to use a calculator. Let's see. Calculator. Where's it at? I got to type it in. I wonder if this is getting recorded or not. Here we go. Got it. Twice. Okay. So 8.5 times 8.5. Boom. 72.25. So we have 72.25 times mass times 1/2, 31.00. Actually, no. Sorry. I almost made a mistake. No point. It's just 3,100. So, doesn't matter that there's an M here. Doesn't matter. So we're going to do this, and we're just going to do divided by 2. Bam. So 36.125. So 36.125 M equals 3,100. And then just memory plus that. Clear it. 3,100 divided by memory recall. Boom. 85.81. There we go. So mass equals 85.81. And then it should be kilograms, right? Cool. So there you go. Hopefully that makes sense to everybody. So recap. We put everything where it was supposed to go. We squared this. We multiplied it by 1/2. So this was squared, multiplied by 1/2. Divided that over, because we got to get the mass by itself. Zoop. And that was it. We're done. It's kilograms because, hey, what is the rider's mass, right? So we're done. Alright, so there's my calculating for the time. I'm not going to do that. I can do that again. Let's see, what's this next page? Is it still the same thing? Alright, we'll do one more, and then we'll go to the next page. Alright, the first asteroid to be discovered is Ceres. It is the largest, most massive asteroid, blah, 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 blah. It has a mass of that, okay. And it has the speed of that. Determine its energy. Oh, this is interesting. This is interesting. So, let's see. We have our mass. I'm going to skip some steps here. Kinetic energy equals 1/2 times mass times velocity squared. Kinetic energy equals 1/2 times... I'm leaving this in scientific notation because it's huge, and I don't want to mess with this number. So, 3.0 times 10 to the 21 times 17,900 quantity squared. So we got everything we need. We just have huge numbers. So you're going to have to use a scientific calculator for this one. There's no way around it, right? So yeah, determine the amount of kinetic energy possessed by Ceres. Okay, so you've calculated that. You punch that in, so you should get 4.8 times 10 to the 29, I believe. And then we know it's joules because it's energy. So that's a lot of energy. Let's put that in perspective. Let me look something up real quick. Hold up. Okay, so I looked it up. Actually, 2 times 10 to the 32. So it's not quite enough energy to like destroy the entire Earth. This is how much energy. 2 times 10 to the 32 joules. Whereas this is 4.8 times 10 to the 29. So that's a bit smaller. But this was pretty much at least obliterate, like, let's say like half of the Earth maybe? Like a whole like population? Whole hemisphere population? Alright, cool. Well, that was fun. Let's do a few of these other ones and then we're going to call it for this one. Because it's going to take a long time. So this is that easy stuff, right? Remember how the other page we were doing where it's like you do this, you do this, you do this, you do this. Alright, easy. So, bicycle has kinetic energy of 124. 124 joules. What happens if it has twice the mass, same speed? So, let's write my formula off to the side. Kinetic energy equals 1/2 mass velocity squared. So, if you double this, you double this. You double the mass, you double the kinetic energy. You double the velocity, you times this by 4, because that double is 2 squared, right? So, after you do a few of these, if it's not easy already, it will be. So, with that being said, twice the mass, so times 2. Which means you just double this. So it should be 248. 248 joules. Got that? Does that make sense? I don't get it. But we don't know the mass. How are we supposed to know it? Who cares? Doesn't matter. Right? If I have this number, if I have 100 equals x times y. If I double this, this is going to be 200. I don't need to know what x is. I don't need to know what y is. I just know that if I double this, this is going to double. If I just double this, this is going to double, right? Because it's not squared. Hopefully that didn't confuse you more, but bottom line, I don't care what this is. I don't care what this is. Because I don't need to know it. Let's look at B. Same mass, twice the speed, right? So in other words, we double the velocity. Well, we just said if we double velocity, we still have to square it. So 2 squared is 4, which means this is going to be times 4. So 124 times 4 is going to be 496 joules, because it's energy, right? So, same mass, double the speed, bam. Pretty straightforward, pretty easy. Let's look at C. Don't let these confuse you, just take them one step at a time. So it has 1/2 the mass, which means I half mass. Forget about this right here. Don't worry about this. I half the mass, which means I half this. So halving the mass halves this, which means it's going to be, what, 60, 120, okay, 62? Yeah. So 62 first, and now I twice the speed. So 2 squared is 4. So you have 62. Now you got to do times 4. So 62 times 4 is, you should get 248 joules. 248 joules. So again, take it one step at a time. Half the mass. So first thing you do is half it. And then the second thing you do is times it by 4. So after you've halved it, you times it by 4, and that's what you get. Pretty straightforward, pretty easy. Hopefully you guys are getting this, right? Next one. Half the mass. No, sorry, excuse me. Scratch that. Same mass, half the speed. So that is 1/2 velocity squared. So the question is, what's 1/2 squared? It's 1/2 times 1/2, which is what? 1/4, right? So you take your original joules, which was this, that 124, and you multiply it by 1/4. In other words, you divide it by 4. Pretty straightforward, right? 31 joules. Bam. Let's look at E. 3 times the mass, 1/2 the speed. Okay. again, one step at a time. 3 times the mass, multiply it by 3. So first thing you do is you do times 3, 1/2 the speed, divided by 4. So step 1, step 2. So you should get 93 joules. Bam. Hopefully you guys got that. Pretty easy, pretty straightforward. Awesome deal. If you guys got any questions, shoot me a message. Goodbye.